so we can share it with everybody else. And just before I introduce our first speaker for the night for the beginner session, I just want to do a treaty acknowledgement. And the lands from which our members and guests are joining us are located on the original lands of Anishinaabe, Cree, Oji-Cree, Dakota, and Dene peoples, and on the homeland of the Métis Nation. We respect the treaties that were made in these territories. We acknowledge the harms and mistakes of the past, and we dedicate ourselves to move forward in partnership with Indigenous communities in a spirit of reconciliation and collaboration. Again, welcome everyone, and I'll ask you all to join in welcoming our first speaker tonight, the beginner session, Scott Young, and he will be giving us tips on public outreach. Please, over to you, Scott. Have a good one.
All right, thanks. Can you all hear me out there? I hope. No answer. Someone let me know that
yes,
my microphone's
working. Okay, I can hear you okay.
Okay,
yeah.
good.
Yeah,
Thanks.
you're good.
Sorry, I had to reconfigure all the audio again. All right, so yeah, my name is Scott Young. I work down at the planetarium, and I've been a member of RASC Winnipeg since I was a kid, basically. And my very first observing session was during Comet Halley, 1986. You may remember this. Now, I had borrowed a telescope from a friend, and I was going out to this star party thing that was in a school somewhere out by Lorette, I think. I don't even know where it was because I was 10. And I heard that if you brought a telescope along, you got in free. Everybody else had to pay like $3 to get in. So I go out to this event and I bring out one of the pieces of the telescope and I get in the door with my dad and plop the telescope down, and we go back to the car to get the other piece of it. And by the time I get back, there's a lineup behind my telescope because people thought that I knew what I was doing. And of course, I had no idea what I was doing. I didn't know how to find, I was there to learn. But I basically started my RASC experience doing public outreach, kind of by accident. And it's been something that I've really enjoyed. I'm so glad that now that we're coming out of the big COVID times, we're able to do some level of public observing again. So I thought this would be a good time to sort of go through a few tips and tricks of things that I've learned over the years, a few things that I've learned that don't work, and to share some of the findings that we found during the International Year of Astronomy, 2009. Some of you out there will have been members of the center way back then. The UN declared this International Year of Astronomy, and there was a huge number of events, and something like 2 million people had what we called the Galileo moment, that first look through a telescope, or that first sort of discovery of astronomy. And we learned a lot about sort of what works and what doesn't from that. So we'll talk a little bit about those kinds of things. Let's see if my slides will advance. So think back to what it was for you that got you interested in astronomy, or how you sort of discovered astronomy as a potential hobby. Was it something like a special event like a lunar eclipse, or was it Comet Neowise a couple summers ago? I know a lot of people sort of first got into astronomy when that sort of appeared in the skies almost without warning. Was it the Northern Lights? Maybe a really bright showing of the Northern Lights. We've had thousands of people in Manitoba recently over the last year or so sort of get into trying to chase the Northern Lights and see them in the sky. Was it something as simple as just being out in a really dark location away from the city for the first time and actually looking up and seeing the stars? Was it by yourself, or was it a group kind of thing? Were you in a group? Did you go to a star party, or did you, like I did, come to the RASC and have your first experience sort of facilitated by the astronomers there? Or was it even something as simple as just the beauty of a sunset? It's hard to say for a lot of people what exactly twigs that interest. Often it's a whole bunch of these things over time that link together, and eventually you just sort of get to the point where you say, oh yeah, I'm gonna do this, I'm gonna try this. When I was 12, I got to look through my friend's telescope. That was the first time I ever looked through a telescope. Sorry, not 12. I guess I was younger because it was before the RASC thing. Anyway, I got to see Jupiter through a telescope. Now, it was one of those little department store refractors that really wasn't a great telescope, but it didn't matter because I got to see Jupiter and the moons and the clouds and things like that. I even convinced myself I saw the Great Red Spot. And that was where I sort of knew that observing the sky with a telescope was really what I wanted to do for fun. But before that, I'm lucky. My founding moment for astronomy was a very precise moment that I could look up well after the fact and find out when it was. It was February 26, 1979, 11:16 a.m. Central Time. That's when the solar eclipse became total over Winnipeg. I got to stay home from school. My mom called me in sick because they were going to lock all the kids in the gym, right? So they wouldn't go blind. And I watched it on TV, but then during totality, we opened up the shutters, looked out, and I saw this amazing sight, and I was just blown away. That kind of experience can be completely formative. And, you know, if you're lucky enough to see a total solar eclipse when you're a kid, it's pretty easy to see why someone would get hooked on astronomy. But often, someone's first experience with astronomy is at one of our events. We set up telescopes for Astronomy Day, or we set up telescopes for First Fridays, or whatever, and people just come out, maybe they just come out to a meeting, and we are their total solar eclipse, or we have the chance to be their total solar eclipse to hook them into astronomy. Here's just another eclipse picture because it's pretty. If you haven't seen a total solar eclipse, April 8th, 2024, it's within driving distance. Much as I love my Canadian friends, don't go east, go south. The weather's probably going to be better. Jay and Judy will tell us all about that in future years. Okay, the International Year of Astronomy, the 400th anniversary of Galileo's first observations with the telescope, where he published his observations, shared them with the world, and changed the world forever. There was a little bit of funding available. Every country had its own sort of committee to do events in that country. I got to work with the RASC and also the Canadian Astronomical Society, the FAAQ, the Quebec equivalent of the RASC, essentially. And we put on a whole bunch of events, and we helped centers put on a whole bunch of events. And really what the committee did was sort of track the numbers. And at the end of the year, we found that, you know, more than 2 million people had come out and had that first astronomy experience. It was pretty cool to be part of an event like that. And every time we do Astronomy Day, every time we set up for any kind of event, we're still adding to those numbers. You know, people that get excited about astronomy tend to have a more positive outlook towards science. They tend to be, you know, a little bit more critical thinking. They tend to want to explore and learn. So we really have an important role to play. Okay, so what does all that mean? How do you get people excited at the telescope? I mean, sometimes it's easy. And I do have to say that most of the things that I'm going to talk about are really not concerned with this kind of situation where you're in a truly dark sky. You know, when we have people out at Spruce Woods or out somewhere else, you kind of don't need to do very much to impress them because the sky itself is so impressive. When you're in the city, though, where you can see, you know, a dozen stars because of all the streetlights, it makes it a little bit harder. So what are the kinds of things that we can do to get people excited? This is where we set up for First Fridays, basically just on the side of the building here. And so we're right on Main Street. There are streetlights all over the place. You really can't see a lot of stars once it finally gets dark. And of course, it doesn't get dark until very late, which is an impediment to getting people out. The only time that it gets dark early enough, it's minus 35 degrees. So there's all these sort of logistical difficulties. Now, Astronomy Day has sort of solved this by saying we're only going to schedule our event around the first quarter moon, because when it's first quarter moon, you've got a moon that is visible in the afternoon and evening before sunset, and you've got a moon that is visible after sunset for several hours. So the sort of most likely times for people to, be out and about is going to have a moon visible. That tells us a little bit about how important the moon is for public observing. I mean, if you can only show someone one thing through a telescope, it should be the moon. And I know for most of us who have looked at the moon before and who sort of plan our schedules to avoid the moon, it can be easy to forget how amazing the moon is through a telescope. But it really is an object that never disappoints people. Nobody looks at that and says, they're always blown away by what they can see. And it almost doesn't matter what phase, as long as you're not right at full moon, you've got enough shadows. So you've got a terminator with lots of relief for the craters. At different points, you've got different craters that are featured or different mountain ranges. I like it right around first quarter because you really get the lunar Apennine Mountains in here. There's craters everywhere, but there's only a few good mountain ranges that really show up. And I like to show people that and, compare to the mountains on Earth and so on. That's the kind of thing that I think really wows people when they look through the eyepiece. And their eyes will work the first time. As you know, if you've done observing, when you look through a telescope, your eyes aren't very good at it to start with. If you're looking at faint things or if you're, trying to focus or things like that, it can be challenging. But the moon is just so bright, it's basically a daytime level of brightness. And so people don't have to work too hard to be able to see what it is that you're showing them. Just a couple more moon shots. The other thing about the moon is that it takes magnification really well. People think that, I think the number one question I've ever got at the telescope is, what power is it, or how much does it magnify? And you can crank up the magnification on the moon to the point of almost ridiculousness because it's just so bright. There's so much light there that even though you're spreading it out, you can put in the 5 times Barlow or whatever and just get a ridiculous close-up view. Yes, the image falls apart at a certain point, but people love it. They love the idea that you can look in close. And then, of course, they always ask, can you see the American flag and all that kind of stuff? So it's a thing that really gets them very excited and provokes questions. And I think that's actually one of the secrets of public observing. You don't want to show somebody something and have them look and then have them walk away and that's it. You really want something that gets them excited and gets them thinking about stuff. One of my early, well, and still mentors, Stan. Oh, are you out there? Stan? Oh, you are out there. Stan's out there. Stan Runge is big on not letting people look at through the telescope for only a few seconds. He basically will hold them there for a full minute so that they can really soak in the view, and that makes a huge difference. In a public situation, if you've got 1,000 people in line, that's sometimes a challenge, but it really is worth it to make sure that people actually get a good view and see everything there is to see. Because if they just sort of take a peek in there, you're not even sure that the telescope was in focus, or you're not even sure that it wasn't moved off to the side and all they saw was the empty field of view. So you really want to get them in there long enough and see what their reaction is and make sure that they actually see something. Okay, item number 2, which almost always satisfies the public, the sun. Partly because it's daytime and it's something that is, as long as you have the safe solar filters, it can be pretty cool to look at as well. And it's also relatively easy to observe from the public's point of view. If we provide the safety, all they have to do is look through the telescope and they can see the sunspots and things like that. The caveat is, during the International Year of Astronomy 2009, there were weeks and weeks where there was not a single sunspot. And so we would do solar observing and show people basically a blank white circle, and they would wonder why we were getting all excited about astronomy, because clearly it was stupid and boring. We have to be careful about what we show people, because if we're giving them that first view, they have all these expectations about seeing all these cool things. And while the sun can be pretty cool for some of us, like I can, on this image here, you can see all sorts of bright parts and you can see a whole bunch of little sunspots and a couple with halos here and so on. the average person won't necessarily see or appreciate that. So the sun is one of those objects that it's convenient, so it's often good to show people, but it can be a little bit underwhelming. So usually when I do solar observing for the public, I make sure the moon is also available, and I have another telescope to look at the moon so that they always get that sort of wow feature as well. The exception, of course, is during an eclipse, when people are excited to see the event itself, the eclipse. But then you've got a different kind of situation. Okay, item number 3, the planet Saturn. I have yet to see anybody look through the telescope at Saturn and see the rings and be unmoved. It is just that kind of object, as you know, that you could just look at forever. Often people are saying, well, it looks like a picture, or is that a simulation, or where's the app? They think that it's not real because it looks so real. Saturn is a wonderful object. It's been so low for us the last number of years, though. It's never at its best right now. It's so far south along the ecliptic that it only gets 25 degrees above the horizon or so. You're looking through the soup, you're looking through all of the haze and the bad seeing and things like that. And so it's just not as good as it has been. That'll turn around. Saturn goes around the sun every 29 and a half years or so. So 13, 14 years from now, it'll be nice and high in the sky, and things will change. But even still, Saturn is an amazing thing to look at. And it's also a perfect thing to use another technique that I learned from Stan, asking people what they see, asking them questions. Can you see the ring? What color is it? Is there one ring or is there 2 rings? What's the difference in color between the rings and the planet? Do you see anything on the central part of the planet, or do you just see the rings? Do you see any little dots around the image? Those provoking questions can really go a long way into making the public, actually observe, because observation is not a skill that we often do, certainly not very pointed observation like this. So you kind of want to turn people into Sherlock Holmes a little bit and get them to really see as well as observe. Okay, item number 4 on my top 10 list of things to show the public, Jupiter. Not as cool as Saturn. I mean, I got to say, it's probably a step or 2 down from Saturn's rings, because the bands across the planets are not something that everybody sees the first time. Often people will look at Jupiter and they say, I see a big bright dot and some little dots. Well, the little dots are the moons, and those are cool, and you can get people excited about that and telling them about, the volcanoes on Io or the oceans of Europa and how there's maybe life underneath the ice there or whatever. But the planet itself can actually be underwhelming, and especially the Great Red Spot. I mean, people have all heard of the Great Red Spot. It's one of the curriculum points in grade 6 that every kid in Manitoba learns about. And it is really the pale light orange spot at the moment. And it's pretty underwhelming. And most of the time, it's not even on the side facing us. So you actually have to work pretty hard to catch the Great Red Spot and to be able to see it. So Jupiter can be a bit of a letdown for people. And that's even before you get to the idea that people have looked at, the Hubble Space Telescope images, or the, all of these amazing lucky images that you see online or things like that. People have an expectation of a Technicolor planet with sharp, easy to see detail and its giant size. And then when you look in the eyepiece, it's this small little thing that you have to really, really squint at to be able to see details. In my 2009 list, I didn't put Jupiter on the list of things that you should show the public. My top 10 list in 2009 actually stopped after the moon and Saturn. There were 2 things on the top 10 list. And we basically said, if those aren't visible, you have to work harder. You can't just sort of set up a telescope and get people excited. I think Jupiter does make the list now, perhaps because Saturn is just not as good as it used to be because of the altitude. Another factor that sort of plays in here is the new technique of electronically assisted observing, where you basically are live viewing the view from a camera in the telescope. So you don't actually put your eye to the eyepiece, which during COVID is actually great. You don't have to worry about any kind of like eyeball gunk transmission or whatever. It's totally not the same, Darren, you're right. But it's one of those things where you can actually get people to view as a group. I remember when we did the Mars events back in 2009, when Mars was the closest it was ever going to be, and we had thousands of people coming out. We did an event at the Forks, and we had a really crude, by today's standards, video camera in a C8 and a tiny little TV on a stand. And we had that sort of at the front end, and then the RASC telescopes were sort of a little farther in. So people would come in, they'd see the TV image, and it was me or one of my planetarium staff were sort of talking about what you would see. And then they went and looked at the telescope. And that combination actually worked really well, because we could sort of show them, okay, well, this is where the polar cap is, and this is where the dark area is tonight, or things like that. And then when they went to the telescope, they sort of were primed for what things looked like right then. I think there's a place for the electronic side of things, but I agree with you. I don't think it has that immediacy, that sense of wow, that looking through a real eyepiece does. It's one of those things that I'm not sure will ever quite get to the point where a camera view will ever do what you get directly through the eyepiece. And so, yeah, after that, I basically said, okay, back to the moon. Those are the objects that you can guarantee to wow somebody with in a city kind of environment. Well, what about deep sky objects? No. I'm just going to say no. There are exceptions. If you've got a big telescope or you're in a dark sky, you can probably show people some of the brighter objects, and they will get excited about that. But it has to be good conditions, and it has to be a pretty big scope. If you've got your, like the 4-inch refractor that I use for a lot of my public planet stuff, if I had that out, I'm not going to show them the Whirlpool Galaxy or anything like that, because the average person doesn't know about averted vision. So they're not going to be able to use the sensitive part of their eyes. They're probably not dark adapted. They were probably standing in line looking at their phone the whole time. And, so they're not going to have that dark adaptation. They're not going to be looking long enough. And we kind of don't want to encourage the tricks that we often use with our own telescopes. You jiggle the eyepiece a little bit, and that motion helps you see something faint. We don't really want strangers jiggling our expensive telescopes. So faint things really don't work for the public. Now, of course, there's always exceptions to these rules. And I think one of the tricks is sort of knowing when to break the rules and just go with whatever. Sometimes we've been out at Birds Hill Park, and you do a public event, and there's those 2 or 3 people that hang around at the end and just stay the whole time. And they've seen the planets and the moon and all that kind of stuff, and they want more. Those are the people that you show the Whirlpool Galaxy to, or the Andromeda Galaxy, or M13, or whatever. There's a question here. Magnification. What magnification do I recommend for the moon on outreach? You know what? I like to show the whole field of view. I like to show people the whole moon, and I like to let them discover for themselves that the moon is oriented differently in the telescope than it is in the sky, because of course the telescope flips things around or whatever. Stan points out you need a couple of scopes, one at lower power, and then a guided scope at high power. And that actually brings up a really good point. If you're going to crank the magnification, don't do it in a Dobsonian. Don't do it in a telescope that you're going to have to readjust every 10 seconds because it drifts across the field of view. If you're going to use high power, have a scope that is driven. You will just save yourself a whole lot of time and effort because of adjusting things. You're going to have to adjust things anyway because someone's kid will grab onto the eyepiece and pull it towards them instead of leaning into the telescope, all that kind of stuff. So low power for unguided scopes is definitely the way to go. Magnification doesn't really, help everything anyway. I mean, it does in certain cases, but I like to go with fairly low power. And then once people have had a sort of a look at that, I'll pop in a Barlow, or I'll put in a higher power eyepiece. For the public, I tend to use my wide field eyepiece. I've got a 26 millimeter Plössl that I've got that's got actually it might be sitting right here. It's got a good, a big inch of glass that you're looking through. It's really easy to get your eye sort of lined up with that. If I want more magnification, I'll use that same eyepiece and I'll put a 2 times Barlow in, or a 3 times Barlow, to get more range of magnification. Because if you use a high power eyepiece with a tiny little piece of glass, it's harder for the public to really align with that. And if you're using a high power eyepiece with a big piece of glass, it's probably a very expensive eyepiece, and you have to be okay with fingerprints and other things getting all over your eyepiece. It's amazing when kids look through the eyepiece, how much slobber goes everywhere, right? So keep that in mind. I have a set of eyepieces that I sort of use for public. They're pretty good ones, and they work well for the situation, but they're not my top of the line eyepieces. Now, there are a few deep sky objects that you can show people, provided you have a decent sized telescope and a decent sky to be able to show them. The Orion Nebula is a perfect example. You show people that, even in binoculars, if you can get them to find it in binoculars, because of what it is and because of its brightness, it's relatively easy for them to see, okay, that's not just a star. There's something fuzzy about it. There's something weird going on there. And then when you tell them that it's a cloud of hydrogen gas where stars are forming, that is the kind of thing that maybe doesn't amaze visually, but can really get the brain going and get them excited mentally. And that's, as most of the people know, that's more than half of astronomy right there. It's a mind game. It's not just a visual game. You can do the Pleiades. That's about the only open star cluster I ever show people. I don't do the double cluster. I don't do any of the ones in Auriga or things like that. They're just not spectacular enough. They just look like some stars. Actually, an open cluster view in a telescope is what people think the whole sky looks like through a telescope. They just think that's how dense the universe is. So it's kind of underwhelming. The Pleiades, though, big enough. The Hercules cluster, similarly. I'll do that one if I have, my 10-inch daub out. People can see that. Anything else, and particularly galaxies or anything really, really faint, it's just not the kind of thing you want someone to have their first experience at. Now, again, if it's someone that's been around before, or someone who's been there all night, totally different. But you sort of have to treat it like the person looking through my telescope at this public outreach event. This might be their first and maybe their only telescope experience. And so what can I show them that will blow their socks off? And sometimes that literally means that we sit on the moon all night. And yeah, it gets boring for us. But you know what? Each of those people has that opportunity to have that first view. You only get your first view once. And it's, to me, I just love seeing, the light on their eye as they look through the telescope, and you can see the moon is getting into their eye, and you can tell that they're seeing it, and then their face just lights up, and you know that you have changed a life right there. So I highly recommend that you come out to some of the outreach events that will be happening over the next little while. I'm sure we'll be getting more and more into them. And I highly recommend that you just think about what it was that got you into astronomy, and pay it forward a little bit, because the people that we see at these events will be the people that will be running the astronomy clubs when we want to just sort of sit back and relax and drink coffee and, like Stan. Just kidding. I do have to say Stan is one of my inspirations for the public outreach, because he's just done so much for the group. I don't know how many people really know Stan now, but he is a great guy. So thanks very much, Stan, for that. That, I think, brings us to the end of my talk. So if there are any questions, you can throw them in the chat. Otherwise, I'll turn things back over to Dennis.
Great. Well, thank you very much, Scott. On behalf of everybody, I see Darren's got a question there. We'll let Darren ask the one question, and then we'll start the meeting.
Fair enough. Thanks, Dennis. I'll second, first of all, Stan's, the kudos that Scott mentioned about Stan. Stan came by a couple of years ago to help us out with a scope tune-up. This was before COVID, and he was instrumental in helping a few members get started and getting their scopes collimated. So thanks again, Stan. Boy, I guess you're going to get a big head today. So anyway, the question I had for you, super quick, Scott, do you recommend in some ways, like I know you talked about orientation, like even on the moon, wouldn't it make sense to maybe have a erect image diagonal in some of these scopes if they're able to be, obviously a reflector, not so much, but certainly in a SCT or a refractor, there are some pretty good quality now erect image diagonals that would help people be able to see things like the moon oriented the way they would normally look at them. And I think
Yeah, you know, if you
comments on that.
Yeah, if you have the means to get accessories, you know, specifically for outreach, it is great to be able to present the view through the telescope to look exactly like it does in binoculars or to the unaided eye, because then you don't have to get into all the mechanics and optics and things like that. Those can be, you know, not inexpensive bits of kit though, and so not everybody's going to have that. So if you don't have that, I kind of like to ignore it until someone discovers it, because you don't have to get into it until then. And then when you do get into it, the person who discovered it feels smart and, you know, gets that sense of discovery themselves that they notice, because it encourages that, hey, wait a minute, this looks a little off to me kind of sense. So yeah, if you've got one of those, I would totally use it. But if you don't, turn it into a teachable moment.
Great. Thank you very much, Scott. So again, thanks to Scott Young for doing our beginner session tonight and getting us all prepped for public outreach that's going on and starting to be more and more, which is a really good thing. So tonight, as we just mentioned, we had our beginner session. I'm going to just do a welcome, go over through a few announcements, talk a little bit about positions people can volunteer with. Russell and Mark will talk briefly about some of the transition to groups.io that we're moving to. What's up, Brian Stack, and then what's new will be Dr. Michelle Boyce. We'll have a short break. And then the main presentation tonight is on green laser user spotter training, which I'll be delivering at the end. So our plan is to present the amended bylaws in August. This is the first official notice for that. We do now have a privacy policy in place, and financial policy is in the works. These are some of the things that the council is working on. The privacy policy is primarily because members of council have access to personal information through the national website, and we've brought a policy in to guide us to ensure it's not abused. Looking for volunteers as always for meeting presenters. If you have something in a beginner session or something you'd like to do, or a main session, please let us know, and we'll be certain to use your skills. Lonoscope coordinator is Mike Caracas. If you're interested in borrowing, please contact Mike. Our binocular interest group, Darren Henning, who was the one that asked the question earlier, is quite active, and they're using groups.io quite successfully. And we're pleased to be able to use them as an example. Scott mentioned First Fridays at the Manitoba Museum. So the first Friday night of the month is a downtown business event, and we're pleased to be partnered with the Manitoba Museum to provide scopes and volunteers whenever the weather's appropriate. So if you're interested, please keep that in mind, that the first Friday night of every month, we will try to support the Manitoba Museum in their endeavors to reach out to the public. July meeting is the barbecue at Glenlee. Glenlee is not open yet, but the water has receded. We're just waiting a little bit before we go out and then make sure everything's going to stay. The water will stay down, but we're hopeful that everything will be suitable for a barbecue out at Glenlee in July. So look forward to see some more information come out about that. The August meeting, we are planning to do an in-person meeting at the U of M in our normal location. The thing to remember about this is we can no longer have food or drinks at the University of Manitoba. So we are looking at other possible locations in the future, but we will be meeting in August in person at the U of M, and we will endeavor to do our best to live stream the event. We're not so sure that we'll be able to do a Zoom event for interaction, but we'll let you know what we do have available. And if you're unable to travel, how you'll be able to at least see the meeting. Public events, we're still working with the Peace Gardens. It's gone quite a little bit, so I have no more details for you. As we get more details, we'll let you know. And again, our Sprucewood Star Party is the 1st to the 5th of September, and Sylvia talked about that the last meeting, and there is information on the website. So volunteers that we're looking to ensure the center stays viable and effective for everybody. A meeting coordinator, a volunteer coordinator, a spring Star Party chair, Explore the Universe coordinator, webmaster, mentor coordinator, meeting presenters, as I mentioned already, members for the finance committee, and the observatory committee, who are volunteers to train new members of the Dome and et cetera, as well as just administer and run and operate the things that need to be done to keep the observatory functional. The volunteer position I'll talk about a little bit about tonight is the Explore the Universe coordinator. I am currently in that position, and primarily the role is to promote the various observing programs of the RASC, and you coordinate our members' applications for recognition. And you also review all applications for all the different programs, and for the initial Explore the Universe program, you are actually the one that will do the review and final recommendation for issues of the certificates. It takes about an hour a month on average, and it's a fairly easy program to run. Ideally, you put together some objects and things to be in the newsletter so that those working on the certificates are able to move forward on that. So what I'm going to do now, I'm just going to check my chat quick. Okay. And we're going to let call on Russell Brown and Mark Irvine to briefly talk about our transition to the groups.io platform. So Ed, can you make sure they have access? There we go.
All right, I'm going to share my screen here right away. So I'm Russell Brown. I'm Russell, only been a member for about a year, so you'll face a lot of you, I'm sure. Am I able to do a screen share here?
Yeah, just sorry, Russell, just give me
No
a minute.
worries.
Where are you here? Just give me a minute. Okay, try it now.
There we go. All right. All right, groups.io. So groups.io is going to be our new communications hub for the center. Right now, our communications are kind of divided 3 ways. We have SiteGround, which is whenever you get a message from Ed about these meetings and stuff like that, that's being sent out through our web hosting service. We have our forums on the Winnipeg.rasc.ca, which is what's been being used for all the interest groups, the binocular observers, astro sketchers, astrophotography, just general forum chat. And then there's also a University of Manitoba email list, which is still quite active. There's a lot of conversation happening on there, but a lot of the new membership, and not just new membership, not everybody has access to that. And the support from the university can end at any time. So we have decided to migrate all communications onto this new service called groups.io, and it's going to basically replace the features of basically the best of all the worlds. So we're planning to roll this out on July 22nd. I'll give a quick rundown of the service here today. We'll have a special meeting next Friday, June 17th. It'll just be a town hall style Q&A for anybody who has any questions or concerns about migrating to this new platform, or any questions about how this, or specific questions that I don't cover today, about how we how this is going to operate. But I'll quickly give you a quick rundown. So this will be our main site. So groups.io, we have, this is going to be our address. So once you go to RASC Winnipeg, RASCWPG.groups.io will get us to this main page. And on July 22nd, or the dates, whenever we roll this out, all current members will be added to this group. If you're to go to this page right now, you won't have access to it. We don't have it active for the current membership, but once we add you, everybody will be on this main page. And this is what we call sort of the parent group. So this is what we will use as council to communicate all meetings, and this will get, everything will be sent directly to your inbox. You'll have the opportunity to change your subscription level to individual messages. So every message that we send, you'll get an email for, or you can have it featured as like a daily digest, stuff like that. You can make a signature block for your posts if you want, but it'll be up to you how often you receive the messages. So if we send multiple messages a day, you can choose to have only one email a day. But we will use this as our primary source of communication. Subgroups. So this is where our new forum will be. This will be our interest groups. So you'll be able to go here. You can see the ones that I've already subscribed to. And then you go down and you can see, let's say I wanted to subscribe to the beginner mentorship program. You can click on there and simply join this group. If you want to unsubscribe from a group, you just simply send an email to this address and you're unsubscribed. You do not need to be subscribed. So the subscription is only if you want email notices sent to your inbox. So whenever discussions happen in the forum, if you're subscribed to the group, you'll get an email notice that a message has been sent to the group. But you do not have to be subscribed to log into groups.io and view the forum. So as Dennis mentioned earlier, the binoculars group has already been set up and they've been active on here. And this is what it will look like when we launch it. So this is your sort of your forum format. So you can see the topics, you can click in and see the whole email history. And all of this is being sent by email. So you have the choice of either sending an email to, so if you want to post the binoculars group, you would simply send an email from your own personal email address to this address, and it would post into the group as a forum. Or you can log in, click on the topic, and simply scroll down. Oh yeah, reply, there we go. And then you can reply, add your attachments, add your photos, and use it like a regular forum. And then all the photos are organized into albums. So if you just want to go into, let's say you just are interested in looking at what photos the Astro Sketchers have been putting out, or in this case, the binocular group, you can just simply click on it and you'll see all the pictures that have been posted to that subgroup. So it kind of makes it easy to navigate if you just want to look at the pictures. Yeah, so all the subgroups, these groups will be accessible. You can log in to the websites, and there's also a groups.io app, which you can download onto your phone on Android or your iOS device. And it'll be like just a messaging platform, just like you would have your Facebook Messenger or whatever service you use. Yeah, so at the time when we launch this, we will be putting a message onto the forums that we will ask people not to post onto the forums on the website anymore, because we'll be attempting to archive everything here and make this the active group. And at the same time, anybody using the U of M email list will be asking to transition to groups.io for all that conversation in an effort to centralize and optimize the communication experience for the entire center. I see a hand up. Darren, got a quick question there?
Yeah, no, it's actually not a question, it's a comment. Thank you again for all your work, you guys, especially yourself, Russell, for all the work transitioning here. For those of you that aren't familiar with Groups.io, we were one of the test platforms with the Binocular Observers Group, and it will do email reflecting, not unlike how you're accustomed to the U of M. So I just wanted to add that comment in, Russell, that those that are used to seeing email reflectors and then being able to answer via email can certainly still have that functionality enabled in their Groups.io. So it'll allow those that aren't maybe as familiar with this to understand that they'll get the same kind of functionality there, and you can still do attachments and everything as well. So it's actually a very nice platform, and it seems to be working fairly smoothly for our group so far. So thank you.
Well, thank you for that, Darren. And the added feature as well with Groups.io is that you can pick and choose which interest groups you want email notices for. Because right now with the U of M list, it's just whatever's sent, you get the email for. This one, if you don't really care what the astrophotographers are doing, you can just not subscribe. You can just log in to see it. Or if you so if you don't really care what's posted on the buy and sell, you don't need to get all the notices for that. But it will still all be visible by going in here, clicking on buy and sell, and seeing the posts. And I see James actually put a post on here as well. I saw the same one on the forum. So, but yeah, so you can go in and view what's happening in each group. We do also have, go back to the home here, subgroups. So committee groups. So same thing. The committees, we will be setting up a group for each committee. So all the members will be able to see the committees. I still have to add a couple on here. But you'll see which committees are active. However, only the members of the committees will have access to view and post into these conversation topics. So if you wanted to join the financial committee, you would send an email to the chair and request to volunteer on that committee.
So Russell, we need to move on now.
Okay, sorry, I'm dragging on here.
Yeah,
so that's a quick rundown. We'll have once again a more detailed breakdown and Q&A next Friday. So expect that invitation to come by email. Thank you, Dennis.
Yeah, if you can stop sharing. So
Yeah,
just while we're doing that, just remind folks there that the idea behind this is that there has been some communication issues. This groups.io RASC Winnipeg will be maintained as per the current membership list that National has. So hopefully that will prevent any of the errors or omissions that some people have not gotten notices for certain events. And that's the goal of this, is that all members of the center get the information they want to subscribe to in a timely manner. All right. So again, if you've got questions, you can always send your questions to Russell or Mark, who's on this as well, in the chat, and I'm sure they'll be able to answer your questions as well. And then again, next Friday is an event. As I mentioned, members observing night is canceled until further notice, but we do expect Glen Lee to be available for the July barbecue. So next I'll introduce Brian Stack, who will be doing the What's Up. Please welcome Brian Stack.
All right, thank you, Dennis. Let me get my screen up here. And F5. Okay, I see a problem here. I'm going to So I'm using a dual monitor right now. Okay, so what's up in a night sky for June, July? I will be touching a little bit of July because of the barbecue. So let's find out what's up for June. Now we'll start with a little bit of the planets. Not much is going to change since last month, unfortunately. Mercury will be a little bit brighter towards the mid-month. Saturn has already begun its retrograde motion, so it's going to look like it's tracking back. And again, Venus, Mars, and Jupiter and Saturn, all those planets are going to be pretty much in the morning planets. Saturn is going to rise a little before Jupiter and Mars. Okay, so what's next? Okay, for June events, this is what I have so far. Okay, again, it's the same thing. I've seen the same thing over and over again. Saturn's going to be a few degrees off to the moon. Same thing with the other planets throughout the month, and that's also include July. Neptune's going to be stationary on June the 28th, and we do have a new moon on the 29th. With the full moon on the 14th, we're going to have larger tides, and that's probably because it's a little closer to the Earth. Okay, now I came across this when I was playing around with the model. As you can see here, Starlink is going to be up tonight. It's going to start roughly about 11:30. If you were there at the lunar eclipse, I've seen it. I know Scott Young has seen it too. It's quite nice. You'll see a string of bright stars that'll be moving across the sky. This is just the start of it, but over here, I don't know if my pen's not working. All right, so it's not working. Okay, so you can see there's a new moon. There's a moon here. I'm going to bring my cursor, and I don't even have my cursor here. Okay, so anyways, that's something we can look for tonight. Dennis? Dennis, can you hear me?
Yeah, we can hear you, Brian.
Okay, something went wrong. My screen froze for some reason, so I'm gonna hit 5. Here, I'm going to close it down. I'll be right back. Hi, Dennis. I guess I know what went wrong, but
Do you want to just verbally give your presentation?
I need the pictures there. I'm going to start it up again. Sorry about that, people. I don't know what happened.
We could wing back around to you.
Sorry.
I could do mine, then we can wing back around.
Oh, okay.
Why don't we do that, Michelle? Brian, that gives you a few minutes then to sort out, and we'll just have Michelle, Dr. Michelle Boyce.
Sure, okay,
What's
thanks.
up?
Yeah, if you're running more than
Question.
one monitor, you might want to switch to one. Sometimes I have things crash on me if I don't. But okay, I will. Let's see. I have
Thanks, Michelle.
20. Yeah, I have 20 minutes, so because I may actually consume the 20 minutes this time. So I just want to make sure. Okay. Oh, 1 second. I have to share screen and I'm good to go. Okay, and okay, can people see that and hear me?
Yes, we can,
Yep.
Michelle.
Yes, we can.
Yep.
Where's my, I guess you can't see me though. Oh, there we go. Okay, I was going to give up on that for a second. Yeah, okay, so this presentation should take about the full time 20 minutes. You might say that I was lazy. I've been teaching life in the universe, so I've just grabbed a couple of slides and threw everything together. And that being said, I tend to add updated information to my slides. So some of so basically I'm going to talk about exoplanets and life. I'm not going to talk about the origins of life. That would be yet another thing of presentation. We're going to talk about how our solar system formed and how that's related to exoplanets and how we find exoplanets and how we're now getting to the point where we can start to talk about the habitability of exoplanets. So this is somewhat inspired by James Webb and being lazy and tossing my lecture slides out. So I've removed any technical stuff as much as possible. So this is just sort of a schematic of our solar system. And in order to understand exoplanet systems, we'd like to understand our solar system and maybe how that forms. So it has some properties. We can see that we have inner rocky planets here and then gas giants. And in fact, although this is a schematic, the distance of the orbits grow progressively larger as you go out. And the orbits are roughly circular. They lie in the same plane. The planets rotate for the most part in the same direction. There's exceptions like Uranus has to be a complete, okay, I'll blank that out. And then Venus is kind of not rotating. It's almost going retrograde. And then we got a bunch of junk around the system, which is all this dust from the Oort cloud to the Kuiper belt to the asteroid belt. And although this is a pretty picture, there's a lot of garbage strewn around. This is just where most of the garbage lies. That being said, this is a bit deceptive. It looks like it's really clustered, but everything's so scaled out that there's a lot of space between this debris. Otherwise, we would be in trouble. We'd still be bombarded by garbage. We still are, but not to that large extent. We're talking hundreds of thousands of years between impacts. So how did our solar system form? Well, René Descartes was one of the first to consider the solar system model. And basically, actually our universe is about 98% hydrogen and helium, just from the Big Bang. And there's about 3/4 hydrogen to a quarter helium. And then the rest is gas and dust. And our solar system formed about 4.6 billion years ago. Our Earth is 4.5 billion years. And to give some sense of that, our universe is 14 billion years old. So this was sort of just a conceptual model by René Descartes that you had a gas cloud and it collapsed and formed planets. And it got hot because it collapsed, because as you compress a gas under gravitational force, it heats up. So that heating perhaps causes fusing the planets. Laplace was a mathematician and actually put some mathematics to that to make it more slightly more rigorous. So, well, as the cloud collapses, it spins into a disk. So we see this nebula and it collapses into a disk. Unfortunately, this doesn't get us any further. So we have to the picture today. So we have to add to this, and this whole model becomes what's called the condensation theory. And the key to the condensation theory, if you think of rain clouds, well, how do those raindrops fall? Well, they have nucleation sites in general, like dust particles, and the water collects on the dust and they nucleate. Well, in terms of nebula theory, these star factories, we have 10 micron sized particles, which were determined by radio telescopes, just as ALMA in these clouds, mainly little rocky particles, little metal bits and ice, and it's strewn throughout our galaxy. So as the cloud collapses and spins, we get these nucleation sites, and those start to form these little planetesimals, little tiny things. And as soon as they get in large enough, gravity starts to take over and just collect more and more material. All of a sudden, boom. And remember, I said that our solar system is 4.6 billion years, and our Earth is 4.5 billion years. So this, that time scale is happening fairly quickly. This is an artist's conception of a protostar in Uranus and in Orion. And here it shows what's called an ice line. So inside, as you get closer to the nebula, it's hot. And as you go out, you get what's called, well, or snow line, you get colder, icy bodies. So we tend to think rocky planets will form more inside here, and the icy or gas giants will form outside. Sometimes they're called gas giants, ice giants, or Jovian planets. So this whole process is called accretion. And these things, they get larger, they collide into each other, and they get fragmentation and produce planetesimals, which are, like Pluto-sized rocks. And those then collide, and then the bigger ones that will eventually become our planets are called protoplanets, and the hot core is called a protosun. And so our early solar system might have looked like this, and then we had a battle royale of all these colliding and crashing bodies from which presumably our moon was formed almost at the very beginning during the Hadean period, or the period of hell, as they call it. And so we got, in the end, our rocky planets. And this is just sort of a temperature map and the distance in astronomical units. Jupiter is out about here somewhere. You can actually see Jupiter, Earth. And in here, it's so hot, we get our sun forming, and then metals, and we have these condensation temperatures. So the metals and rocky material tend to form closer in where it's hotter. The ice compounds tend to form out by the frost line, forming icy planetesimals, which gas, hydrogen gas, and helium could collect to form the ice giants. And similarly, our sun forms. So this represents some star factory, and a shock wave hits it. It usually requires a shock to collapse the cloud. And in those star factories, you can have many shocks and many of these things forming like this, and you get a collapse. This is a nebula, and it collapses into a disk and then a star. And over here is what's called a Hertzsprung-Russell diagram. And if you go from left to right here, this is basically the temperature, and it's the color related. So red is colder, and this blue-white is the hottest temperature. And ours is the G-type star around 5,000 Kelvin. And this just shows here how bright the star is. And these are the main sequence stars that sit here for 90% of their lives. So Q in our sun as a protostar, and it sits here, it's got to rest here for about 10 billion years. And then eventually just climb off that line. So this is a map of the solar system. So what I've got here is this is kind of where the sun is forming, the rocky planets, and then this whole thing here has to do with gas giants. So we have our solar nebula, protoplanetary disk, protosun, and then the quiet sun boot up. And we have the condensation of our inner rocky planets from metals and rocks into inner protoplanet formation to our planets. And then we have the core accretion, where we have the icy planetesimals gathering more and more gas to give us our gas giants. However, it might be suspected that our sun had a Itari phase, and in that case, the gas giants would have had enough time to form, and so a lot of the gas would have gotten blown out of the solar system. So one idea is called the giant planet migration theory, where Jovian planets have much further out and then are knocked in through the battle royale with all the planetesimals closer into the solar system. And then there's these called instabilities, where there's turbulence that creates the gas giants rapidly enough. And the fixed moons of those gas giants are also created similar to a planetary disk. And then we have our garbage here, asteroids and so forth. So as I said, our sun spends 95% of its time here at a relatively the same temperature, just slightly heating all the time. And then eventually it will become a nebula, just blow off its outer core. It'll expand out to about Earth or so, and then start cooling and become a white dwarf. So this is sort of a timeline here showing the relative scale of time. Here's the proto-sun. Here's our sun sitting here for almost 10 billion years. So about 4 or 5 billion years later, our sun's going to become a red giant and then just slowly die away. So if we look at, I don't know how my time's doing here. Oh, okay, I'm doing okay. So if we look at how that compares to exoplanet systems, well, here's the plot of some exoplanets. So along here is the orbital distance, right? And you can see here Venus, Earth, Saturn, and Neptune. And then here's the orbital eccentricity. How if it's higher, it means the orbit's more squished. If it's a lower number, like 0, it's a perfect circle. So you can see Earth, all our planets seem to sit in circular orbits, but a lot of the exoplanets that we've discovered have very elliptical orbits, and most of them are closer in. And also these dots are relative sizes compared to Jupiter. So we see these Jovian planets much closer in. See, here's Mercury and our sun's over here. And the question is how to get there. Well, that's why we have the giant gas migration theory, where the gas giants formed out beyond the snow line and then somehow got knocked in closer to the star. That's the only way that would fit within this model. I don't think I'm going to get too much into this because this is time consuming, but what we have here, whoops, oh, I'm having problems with my mouse. What we have here is density this way. You can see this is the density of styrofoam, density of water, density of lead, and this is planetary radius and Earth units and Jovian units, and then this is the distance from sun in astronomical units. And so these green dots are planets, and this yellow band here are rocky planets, and then super Earths that are larger. And then in here, these are like water worlds because they're the density of water. And then we have our regular Jovians and our hot Jupiters. So this is sort of gives us a broader picture and a different way of looking at things. So how do we detect exoplanets? This is a Gaia mission that did test planets that are closer, where we can observe distances and so forth and detect their motion and everything. And that's used to get the distances from the stars. So the direct method is trying to just use images. And here's a giant, large binocular telescope that's looking at this system, and you can look at the planets and study it. So here's a star that's blocked out. You can see the planets orbiting it. This method really requires high resolution telescopes and doesn't really get you many results because there's not many systems that are close. So we can use what's called gravitational tug method. You can see here's Pluto and Charon. And notice they're rotating about the center of mass. And it's from that, if we know how the semi-major axis of this orbit, how long this longest distance is divided by 2 and its period, we can actually determine mass of the orbiting body, knowing the mass of Pluto. That applies to our solar system too. Here's a diagram And it's actually surprising to note that where Jupiter is now, if you remove all the planets, the center of the mass of our solar system is just outside the sun. That's how much influence Jupiter has on the sun. And all the planets, if we watch the sun move around as all the planets move around over a period of 65 years, viewed about 35 light years from where we are, 30 light years from where we are, we can actually, from that physics, work out all the different bodies there and roughly the masses. And the longer we do this, the better precision. Then there's another, so that's one way of measuring gravitational tugs. The other is the Doppler effect. As the star comes near us, the light wavelengths are shortened and we see blue. This frequency shifted into blue, and it goes away, the frequencies are shifted into the red. And we can get this velocity graph from the time in days and then work out the period and use that to determine the mass of that body. So this is a perfect sine wave, so it implies there's only one body, but if it wasn't, we could do some analysis and find out more information. Then, of course, this is the most popular method, which is the transit method. When something passes in front of the star, we can see a dip in brightness, and we can, from that, ascertain the actual diameter of that object. And as it goes behind the star, we can determine the contribution from the star. And so we get a sense of size, and when it comes back, we get the period. And the Kepler one was the one that used that method. Its mission was ended in 2018, and it got over 26,000 exoplanets. This is just a summary of the astrometric method. You get a few observations, so direct measurement of the motion. And the Doppler method, the direct method is up here a few. Doppler method, this has been about 600 detections, and then the transit, more than 4,000. And then we can determine things such as the density. If we know from the Doppler, the velocity and the orbital mechanics, we can get the mass. And then from the transit, we can get the volume and we can get the density. So yeah, I'll just go here. So from that, we can, for exoplanets, we can get period, distance, eccentricity, inclination, mass, size, and density. We can also get atmospheric. So this is sort of a half tribute to James Webb. I've shown this video before in one of my talks, but the James Webb telescope can measure starlight coming from the star itself. And then when a planet is in front, it'll measure the starlight plus the planet's atmosphere, and some lines will be absorbed depending on the gas in the atmosphere. And then you can take the difference between those two. And from that, you can find what's in the atmosphere, or at least some of the stuff that's in the atmosphere. And then you can do some spectrum analysis and see what trace elements are there, and maybe indicate some sign of life. So there's water here and methane in this example. And here's our solar system. This is what Venus would look like from a distance, and our Earth and Mars, I believe. And you can see here some ozone detection, and ozone is produced by O2, and O2 is generated by life. So this is a signature that there may be life on such a planet. And then habitability, where can you exist around a planet? Well, if you remember, I said the color of a star represents its temperature. So just by looking at this plot, I can see these are cooler stars here. These are brighter stars. And so for the cooler stars, I have to be in closer, and for the brighter stars, I need to be in further away. And we can get some sense of things by looking at our Earth. So these are surface water worlds. And here you can see the different habitability zones for our solar system. Well, we know where that is. It's somewhere between Venus and Mars. Hotter stars would have to be further away, and cooler stars closer. And we're defining habitable zone here in where we can find liquid water due to the brightness of the star. And the interesting thing is the cooler stars live long time, like longer than the universe is old right now. And so maybe there's advanced life there. However, there's a caveat. If you're closer to such planets, there is ultraviolet radiation. And this just shows the habitable zones here. And we have Earth is basically sitting in the Goldilocks zone, and Mars and Venus are on the outer edge. Venus has a runaway greenhouse effect, but we recently detected phosphine in the upper atmosphere cloud decks, and there might be life there. I also gave a presentation about this some time back. And then there might have once been water on Mars. Mars is significantly smaller. It doesn't have a magnetic field, so its atmosphere could have been blown away. But we suspect there might have been ancient oceans and fossils. And this is just a summary of here, these cooler stars. They live 6 billion years. So that's a long time. And these hotter stars are 50 million to 500 million. So we don't expect as much time for life to form on these stars. It's basically from our sun and any hotter stars, we would expect the potential for life. So those are the ocean worlds. I had given some presentation also about life on so this is subsurface ocean worlds. If we want to go outside our habitable zone, yeah, I'm doing okay. I got 4 minutes left, I guess. If we want to go outside our habitable zone, we have to consider oceans underneath surfaces. And our solar system has some examples. So I had given a talk once about Enceladus, and here's the crust on Enceladus, the moon Enceladus of Saturn, and some volcanic vents. And all this material here produces an environment conducive to life. Here's an example of life found down in a gold mine of South Africa. And it's basically living off chemicals created from pyrite and uranium through these reactions in the water, where we can create oxygen and sulfides for aerobic type life and anaerobic type life. And we also find life of this form without any light living around volcanic vents. So that gives us some plausibility. The more important thing to note here is we have water, which is important, but we also have contact with bedrock, which is also important because those minerals are important also for forming life. And here I'll just do a quick survey of possible places. Ceres, we found stuff on Ceres like very briny, salty water, so it's possible. Europa, around Jupiter, we believe there's a very large ocean under there, and we think that there could be life under there. Ganymede is locked, so it has water, but we don't believe there's life because the water is actually trapped in layers of ice. There's no contact with bedrock, so they call it locked because it has no minerals and stuff to start life going, any life cycles. And so bacteria and stuff that don't use sunlight require these nutrients in order to survive. Similarly, Callisto is locked. And so that brings us to Enceladus, which I've mentioned. So that's active. There could be life there. Titan, underneath the surface of Titan, there's ice and water, but we're not sure if it's locked or not. So there could be life there. Venus, the surface, sorry, did I say Venus? I meant Titan. The surface of Titan has methane lakes, and if there is life there and organic rain and stuff, it's not life as we know it. So there's quite a bit of interest in going back and visiting. Mimas, which is another moon, is a possibility for life. We don't know if it's locked, but there's evidence, and this is a moon of Saturn. And then the final moon is Triton, and there could be possible life there, moon of Neptune. And then of course we have Pluto, which I've talked about this before, and there's a possibility of life underneath due to cryovolcanism. And then we have water worlds and super ice. Water worlds, they're kind of more massive. They have more hydrogen in the atmosphere, and same with super Earths. That means is there's more greenhouse gases. They can live out further than our habitable zone. They can live out by Jupiter. So there's a potential for life there. We can have habitable zones around binary stars. I'm going to skip that. Rogue planets, pulsars, and that brings me to the end here. And this is just a survey of what we know today in terms of exoplanets. We have hot Jupiters, gas giants, ocean worlds, rocky planets, and larva worlds. And here's our Earth's orbit and our Earth size, so you can get a sense. And these are all the types of surveys that have been done. And with that, I I am done. Thank you.
Thank you very much, Michelle.
I think that was a
So-
lot. Sorry.
It was, but it was interesting. Thank you very
Yeah,
much.
I should have cut it just a bit, but
Yeah.
I tried to keep it in the time slot though. Okay, I will end here.
And we'll go back and see Brian. Do you want to give it a try again?
Yes, of course. I apologize, people. Dennis is disabled. Okay, can someone enable me, please?
I didn't. Oh, yeah. Okay. Yep. Hang on. I didn't disable you, so it did it all by itself. And you try that there, Brian. See if that works.
Okay, that works. Okay, thank you. All right, so I'll click on this and now I can see application. Great. I'm going to hit F5. Okay, so let's start this again. So what's up for June, July? We're going to be brief now because we're running probably a little behind right now. So we'll just advance a little bit. All right, as I mentioned earlier, we have the Starlink here. So I got my pen working now, and you can see all these little dots here are going to be the satellites coming through. So hopefully tonight, if the model is correct, we're going to see some of the Starlinks there. As I mentioned before, if you're out near or during the eclipse, I saw it too. So a lot of people saw it. It was quite spectacular. It was unexpected too. All right, so as I mentioned here, all right, so we do have, I gotta move the screen over. Okay, so we have all these planets lining up right here, and this is towards the end of the month of June. What's nice about it is we do have Mercury. Mercury's going to be there, but of course we're going to be quite close to the sun. Now this is going to happen on June the 23rd, the 24th, and the 25th. Now what's on the 25th, we're going to be a little bit of a crescent moon there. So again, all these planets are going to be pretty much early in the morning. Saturn's going to rise up a little earlier around 2:30. All right, so we'll just skip this. Okay, we do have the Milky Way. Unfortunately, it's not going to be really dark enough, but we do start to see a little bit more of the core. But the nice thing about it, around 2:30, it's going to be directly overhead of us. Now in July, the 26th here, now it's going to be, 4 degrees south of the moon. But if you notice here, this is going to be a very thin crescent moon. So that's going to be interesting to see. Again, it's going to happen pretty early in the morning around 4:30. Now, solar activity, again, it's on the rise. It's above the predicted values. So again, expect some increase in the aurora borealis. So that'll be interesting to see. Again, this is a quite unique year for us. We're in cycle 25 right now. And it's summertime too, so it's going to be pretty warm. Now, this is something I want to bring up early. I really like this idea because if you know summer, if you know Winnipeg, you know the summertime, we have a lot of twilight. And when I looked into this, unfortunately, we don't get quite dark skies. And we do have 3 different types of twilight. Of course, as illustrated here, Civic is going to be 6 degrees below the horizon, the sun. Then we have the nautical twilight, which is going to be 12 degrees. And this astronomical twilight, which is pretty much going to be dominant throughout the whole month of June, it's 18 degrees below the horizon. For us, it'll never get dark. And as here in this diagram here, when I looked to the observatory handbook, as you can see here, in June, it'll never get dark. So as you see, there's no data here, it'll never get dark. And this graph is supposed to represent this gray area right here, supposed to represent the astronomical twilight. So it'll never get dark for our latitude. Starting in July, around 19th, it will start to get a little darker at 11 o'clock, but it's only going to be a few hours. So, and of course, there's other factors too that contribute to the brightness too. Of course, restaurants are open, right? It's summertime. So they're going to be open until 2 o'clock. So that can contribute to some of the pollution there. Now, this noctilucent clouds, this is the season for it because of that astronomical twilight. Where the sun's going to be 18 degrees below the horizon, and we're going to be just in the right position to see it. It's only those people above the 50 degrees latitude are able to see it. Now, these are basically ice crystals that form roughly about 80 kilometers above in the atmosphere. So again, they're ice crystals. They're translucent. They're more like cirrus clouds, and they kind of give it the blue silver kind of a hue to it. So again, we're in the position. We're in the summertime. We'll be able to see it now. Okay, so we have July 19th. Okay, so we do have Jupiter. It's going to be a few degrees. The moon's going to be, or Jupiter's going to be a few degrees north of the moon. So that's for next month, though. Again, this happens later in the month. Okay, I'm pretty sure I captured some of the nocturnal clouds there right here, noctilucent clouds. So this happened early in the morning, not in the evening as some people probably expected. So it does happen early in the morning. It was pretty nice when I caught this comet neowise back in 2020. All right. Again, well, where do I go and look for it? How do I know it's going to form tonight? Well, you can always go to spaceweather.com, right? You can also go to NASA too. NASA can help you out if it's going to be forming. This is last year. You can see these clouds forming. So it's going to be with us definitely for this summertime. Now, for next month, as I mentioned earlier, we do have a meteor shower for next month on July the 29th. What's nice about it is we have the new moon. So hopefully we have some clear skies for that for next month. Well, it could be good. And of course, it'll be summertime too. So it'll be nice and warm again. Now, what was the forecast for next 10 days? Well, it's promising, not for this weekend though. Next Saturday, it's going to be in the high 40s. So but it'll still be pretty warm. Now, for the cloud coverage here, starting next week, you can see here that we're going to have some clear skies. And Saturday, that's where it's going to be plus 40. But this weekend, and this keeps fluctuating. I keep monitoring this. You know, unfortunately, Sunday it's going to rain, but we don't have very much for clear skies. Maybe a little bit in Sunday night, but I do expect some rain this weekend. So I think that's it. That's all I have to say for what's up for June and July. Thank you, everyone. Have a good evening.
Thank you, Brian. So folks, what we're going to do is we're going to take a 10-minute break, and then we're going to start with come back and we'll do the green laser pointer training session. So 10 minutes from now, and we will begin the next session. And what will happen is we'll stay on and people can just chat and visit with each other while we're waiting, take a short break, go get a drink of water, whatever the case may be. Darren, I see your hands up. Go ahead.
Thank you. Just quick.
And just welcome everybody back. And I'm going to share my screen. Let's check the chat here before we get going. So good evening, everyone. My name is Dennis Lyons. For those of you who don't know me, I'm president of the center, but also I'm the Green Laser Pointer chairperson for the RASC National. And I've done some work in the past with Transport Canada to get global permits for the RASC for us to be able to use green lasers. And I'll go through some of the rules and regulations tonight as we go. One of the things I ask you to do is check to make sure your names in the that are showing up are full. If you can, put your full name in there, because we're using that to be able to record as our proof of who attended the training, because it's a little harder in a Zoom. And I've got 24 participants, and hopefully everyone, all 24, will be eligible for certification if they so choose that. So again, welcome, and I'll just get started here. If you have questions at any time, I will do my best to answer them as they come up, okay? If it's something I know I'm going to talk about in the next slide, I'll just say I'll cover that in the next slide. But if you're not sure about something, this is the time to bring up your questions and we'll go through it. And I've done this by Zoom 3 other times now with other members of National, as well as some other centers across Canada. So the purpose again of the training is for you to gain certification as a green laser pointer user or spotter, and upon successful completion of the course, and there is an exam at the end, you will be granted that authorization. Thanks for taking the time to do this and sharing your love of astronomy with the public. We've sort of got a theme going here tonight about public outreach. So things we're going to talk a little bit about is the interim order, and the interim order is what started all this, and it's now moved into regulation. So the next time when I update this after we apply for our new permit this month, which is usually issued in July, it will be making reference to the actual regulations. Now we will talk briefly about the regulation that's in place, but it's been expanded greatly to incorporate the items in the interim order. So the interim order and the regulation deals with the actual possessions of lasers. So believe it or not, if you have one of these and you go outside your home, you are actually breaking the law. A laser, a green laser pointer, is only legally allowed to be carried for somebody that's using it for either scientific purposes, and specifically the law allows for those in the astronomical societies going to an event where they're going to use a green laser pointer. So understand that there's a law actually about possession of pointers. It talks about the maximum 5 milliwatts of power, provides links to the interactive map, and it's now been made into regulation. As I say, and our new permit will apply to that, but primarily provides for the exemption for the astronomy use, which is what we use it for. So the regulation that people need to remember, this number, it's easy to stand out. It's regulation 601.20. It is enforceable regulation with fines and penalties. And the penalties can be quite severe, $2,000 and up, depending on the situation. It deals with the projection of any bright light into airspace, air above us. So a question I'll be putting in with our next application to Transport Canada was asked, does this rule apply to LEDs? And because it talks about bright lights in particular, I would suspect it does apply to high-powered LEDs now. But that's a question of interpretation, and I don't have an answer for it. In our case, it's primarily dealing with the use of lasers for public outreach during astronomy. And in that regulation, there's a requirement to apply for a permit to project into the airspace. In Canada, airspace is anything from the ground up. So as soon as you step outside and turn on a laser, you are projecting it into airspace. So the rules apply. Now the original, not the original, permit process as it's written is very, very complicated. And it was really intended for when you see on Canada Day and they have these big laser light shows on Parliament Hill, it was meant to deal with those. So it was never really meant to deal with the things that we use in astronomy for public outreach. So Transport Canada worked with us and the FAAQ, which is the French Astronomical Association of Quebec. And with us, we were able to work through a process to come up with a simplified process to get a permit so that we are in compliance with all the rules and regulations of Canada. So in order to use our permit, though, the following things must be complied with. These are conditions of our permit. You must be an adult, 18 years of age or older. We chose 18 years of age because it was a generic age that fit most provincial laws. And it tends to be the one that's used primarily. You must be an RASC member in good standing for at least 2 years. Now, the reason 2 years was chosen is we didn't want people joining the RASC so that they had a way to be able to carry this and possibly use it incorrectly. So generally speaking, if a person's been a member of the RASC for 2 years, we consider that to have been a member in good standing to be issued a permit after training. Authorization. And you must have completed this GLP training course successfully in the past 3 years. Now, 3 years is used because that's a standardized training. When we do our training and review the exam, we're going to correct to 100%. Standardized training is based on the concept that you're going to lose 10% of your knowledge every year. So that brings you down to 70%, and 70% is a minimum knowledge to be able to conduct something you've been trained in. It's very generic, very simplified version of that, but that's why that number of 3 years has been used. I'm just going to take a minute and look in on the chat here because I see there's several things here. So in order for you to get recertified for another 3 years, you need to do the test tonight. It'll be very simple. It's just an online poll that we're going to be doing. Darren has mentioned he's got a meter that can measure the lasers. The challenge there is hopefully you have your tag on your laser, because if you're stopped by the RCMP and they ask to see your laser. So for instance, I'll hold mine up as best I can. On mine, it doesn't focus very well. Oh, there we go. On mine, there we go. That tag actually says what it is and what class of laser it is. So without that, even though Darren could test it, you could be in a situation where you could be challenged on it. But bear in mind, if you've lost that and you're trying to use due diligence and you get it tested by Darren and it meets the regulations, I would record that and use that as my evidence. Okay. The certification is for 3 years. Some people have done that. It's just that for the ones that were done 3 years ago, we're doing it now, just for those that are asking that have done that in between the last 2 years. Okay. And sorry for the delay there. And for the ones that have asked a question about if they're a new member and they do the training and testing tonight, yes, your training will be good. We just would not authorize you as a spotter or user until you've completed 2 years with the RASC. Historical intermittent membership, we can consider that. That would be up to the council to make that decision. Okay, so I've looked at all those. Thank you for those bearing while I reviewed those for those people. So again, successfully completed the course in the past 3 years. The RAC holds a global permit for the use of green laser pointers outside of the 10-kilometer zone around certified airports. Now my link doesn't work anymore. I'm going to show you how to find that. It's very simple. Now, the thing to know about, there's a lot of things that go into the designation of a certified airport, but the simplest thing is they're allowed to have night flying. So hence the designation is that's why we're restricted as the RASC and the FAAQ. Our global permit does not allow us to use it within those 10 kilometers. So I'm just going to escape. Hopefully. And stop share. So to find the interactive map, what you do is all you got to do is put Transport Canada, Green Laser, or GLP, and it'll bring you to this page. Use handheld lasers legally and safely to Transport Canada. If you scroll down a little bit, on this page, you'll see Explore the Interactive Map. So we click on that, and then it will scroll down. Now I'm going to warn you, when you actually get to the map, oh, come on now. Why didn't the link to the map? Here we go. Explore the interactive map, where handheld lasers over 1 milliwatt are permitted. So when you scroll down and you get here, now watch out. If you scroll with your mouse over this, the map will go bonkers on you. What you want to do is to use the plus or minus sign. Oh yeah, now it's going to do it to me. And we're going to zoom in on the area where, in particular, Manitoba, and the areas where we traditionally will do things as the RASC. So if you're planning to use GLPs, any of these red circles are areas where we cannot use it within those circles. That does not mean you can't get a permit, but you have to apply using the long form at Transport Canada and submit it to Transport Canada. So as you can see, we're closing in on some areas, the three different areas within the Winnipeg airspace. And when we look at the places where we traditionally will go and do observations, you'll notice that Okamic Marsh up in this area is outside of those areas. That does not mean you don't need a spotter. You still need a spotter because aircraft can come in on approaches in these areas. The other area that's used a lot by RASC members for public outreach is over here at Birds Hills Park. Now, what you do need to be aware of is this area of the park, you cannot use your lasers. You can use it in this area, but not this area. So I know when Darren does his things, he tends to go out more over this area of the park and that. We've done some work with the Scouts Canada, and they have an area down around here, I believe is the area. So again, technically within the city limits, but outside the red restricted zones. So that's how you would find out. It's important you do that. And then the other area we use, we'll back out just a little bit. If you notice somewhere in here, I believe, I'd have to go back in again, is Spruce Woods Provincial Park. So you can see we're not have any difficulties using our permit in that area. And then again, there are some functions that are done up in Riding Mountain. But as you can see, as long as you're not up in this area of the park, you're safe and legal to use the permit. Okay, I'm just going to check the chat again. All right, so I seem to have answered people's questions. All right, so get out of this one. Let's back into the other one. So that shows you how you can find out whether or not you can use the permit in those areas. So we just gone through that. If possible, record your GPS location and provide it with your final report, because there is a reporting requirement for every time we use the permit. Part of the reason they want us to report is Transport Canada has to spend a fair amount of time going through the reviewing our applications and issuing the global permit. And they just want to justify that it's actually being used and it's worth their time to be able to do this. So it's important, it's part of our condition of the permit to report how often it's used. The reporting procedure for the last 2 years has been pretty easy because nobody's really had public events, but we are moving into starting to do that now. So the big thing here, in order to be able to use the global permit, is you have to apply to your center executive to have the event recognized at least 8 hours prior to the event. So we've made it as simple as possible. Generally speaking, it's done by an email to the center, unless the center decides to have more stringent requirements. Now, our center does not. That's all we're going to do is 8 hours. If there are any questions, if there's no questions, you can consider the event approved. So the email needs to tell us who the user is and who the spotter is and the location and time of the event, so that the executive can look at it. And the reason the executive
make the slide bigger? Sorry, can you make the slide fill the screen instead of yourself, or unless that's on my end?
That's up to you. You'll have to
Okay,
change the setting.
Yeah, I was gonna say, unfortunately, that's not where it is. So I'm just gonna check.
I figured it out. Thanks.
Okay. How about Steinbach? Yeah, so it all depends on whether or not the aircraft's certified. There may be flying going on there, but it may not be a certified airport. So there's a difference. It's a technicality and in the regulations. So again, part of the reason too is the executive, or sorry, council, not the executive, has to make sure that you've complied with all the requirements, as that you're trained. The location is technically outside of one of the red zones. And there are 2 certified spotter users that are going to be at the event. And by doing all that, it becomes a RASC approved event. So the insurance would be in place, which is a condition of the global permit as well. And lost confirmation site. So one of the conditions is you have to be able to prove you are actually a member of the RASC. So you need to have a copy of your membership card, the permit, and insurance with them during the event. The permit currently is an email, which is what Transport Canada did because they're all working from home and they had difficulties being able to actually issue hard documents. So your membership card can be printed off from the member section of the RASC website, and the insurance copies can be requested from the RASC website, but a different area. So what I'm going to do is stop sharing, and I'm going to show you, in case you don't know how to find and print off a copy of your membership and a copy of the insurance certificate. Okay. Okay, so you go to the RASC website, and there are 2 places to log in here. You have one here and one here. So the first thing we're going to do is we're going to log into the secure site login, which should bring us to our membership card. So you click on the secure site. You should get a page that looks like this. You put in your email and your password. And what happens is then you go here, they call it a dashboard. And on this side here, you'll see where it says My Account. So click on My Account and just simply scroll down. Now you can edit everything you need in there, but you'll see this, Print Temporary Card. If you click on that, it will bring you and show you your membership when it expires. So this is important. In time, the hope is that there will be a block that will show that you are current for that year as a spotter user, GLP. That has not happened yet. Anybody who's followed the National Forum knows they've had a significant amount of challenges with their new online platforms. So at some point, the goal is to eventually have a block here that will say GLP certified. So that's to get to your membership card. Gotta do this all over again. So I'm gonna close out this one. So again, you go back to the RASC main website. This is where it gets tricky. Make sure you're logged out of the secure site login, and then you go into just the straight login here. Now, my passwords are the same for both. I don't know if that's the case for everybody. So once you get in there, you'll see it's a different page again, just to make things simple. In the member area, you want to go to membership benefits. So you click on membership benefits. And then you slowly scroll down. You'll see all the information that members need to know, types of membership, types of centers, and member benefits. So then we get down into member benefits, the GA, which is coming up this month, as well as awards, volunteering, and insurance. When you see the insurance, you'll see this blue button or certificate of insurance request. So we click on that. And then that takes us to our public liability insurance information. And if we scroll down, there's a couple of things. So the one you want to click on is a 2022, 2023 or appropriate year general certificate of insurance. For general public outreach, this is all you need unless an organization, so I'll use the Spruce Woods Star Party as an example. The provincial park there requests that that they be named on the insurance certificate. If that's the case, then you would apply for online for event insurance. So I'll show you this one first, the general certificate of insurance. Just click on that. And it comes up, and this is our confirmation insurance. So if the location you're doing the public outreach does not request to be named on the insurance, you can use this certificate of insurance or confirmation of insurance. So, no, it closed everything. So 1 second. I will go back. No, maybe not. So if the place you want to do your public outreach wants to be named on the insurance, now you need to plan at least 2 weeks in advance for this. Sometimes you can have it back within 24 hours of the request going in, but you have to give enough time because this actually goes in to the insurance broker. So you'd need to log in again to view the form, you fill in the form and you send in the form. All it really is it just a form that says you want to name Spruce Woods Provincial Park on the as a co-insured, and that's where that works. So I've shown you how to get your membership card and your insurance copy. So by regulation, the maximum GLP we're allowed to use is 5 milliwatts power or less is all that's authorized. So this is actually where it's not, Transport Canada lists it, but it actually comes from Health Canada and it's a Health Canada regulation. So Health Canada has determined that anything larger is a public health hazard and needs special precautions and everything else. The other thing that you need to know is that it's a class, it must also be a class 3A or a 3R permitted laser. For the laser I showed you earlier, my little green, there it is. That little buddy and on its certificate actually says that it's 5 milliwatts and it's a class 3A laser. So it meets the requirements of the regulations. So that does not mean that this laser is not dangerous. This laser can still cause disorientation to an aircraft crew when exposed unexpectedly and is a major concern for aviation safety. So this is the whole reason from Transport Canada's perspective that there's regulations in place and we have a specialized global permit to allow us to use them. The idea is if you're within that 10-kilometer zone, you run the risk of this having the potential of disorienting crew. I'm in aviation and we did a trial and shone this into a cockpit, made a video to show our crews what potentially could be experienced. And it's incredible how much that light scatters once it hits a windscreen. And if you're in dark conditions, like dark adapted like they normally are when they're on a final approach, That's a critical phase of flight, and it increased the hazard for an incident or accident to happen dramatically. So the whole purpose of this is to maintain aviation safety. So there's a serious reason behind all these procedures and policies that we're following. And again, understand that not just Transport Canada, but there are regulations under Health Canada should you have something that does not meet 5 milliwatts of power or is a class 3A or 3R laser. Unfortunately, both Health Canada and Transport Canada recognize that you can go down to a lot of stores and buy lasers that are way more powerful than this and are different classifications than this. But as a professional organization of volunteers promoting the sciences, we want to do everything we can to promote compliance with this regulation for its intent for aviation, to maintain aviation safety, as well as to allow us to show the public and share our enjoyment of astronomy, the science of astronomy. The other parts of the permit, spotter will be used at all time. The number of spotters you need will be determined by your area, but at the very least you need one, okay? So, and that person is to be in place at all times, and they have to be in a position to clearly observe where the GLP is being used and watch for aircraft that may fly into the area. So aircraft will have position lights that are green, red, and white, and usually a flashing white light as well, or possibly a flashing red light. So that's how you're going to determine whether or not you see potentially, is that a plane or is it a, some other thing flying over top, high altitude, new internet system that Brian was talking about tonight, or is it an aircraft? Well, the aircraft tend to have distinguishing light systems and patterns. What you should do is, while it's in your area, even though you have probably no way of hitting that aircraft, is to stop using the laser for a moment until the aircraft clears the area that you're looking at, or look in a different part of the sky. Just be safe. So we also ask that you report to the executive of your council so that we can report to National Office for Transport Canada's, and that is a condition of the permit. And if you want to keep the permit, report the events. That way they know we're using it and we're promoting it. So there's a question from Darren. I assume that GLP certified members at Sprucewood Star Party can use their lasers based on general event insurance. Specifically, Sprucewood Star Party has to apply and get a insurance certificate of insurance specific for that event. So GLP certified, you still need to have an approved event. So for instance, in the case of Sprucewood Star Party, Sylvia notifies me, usually myself, has notified myself in the past of who's going to be doing the event, who the spotter is, and what day is the event going to happen. So it's already, it's controlled. It's not like if you went out there on a Sprucewoods and wanted to do it on another night, it would probably not be entertained because there's a lot of people doing astrophotography. So when lasers are being used, that interferes with the astrophotographers. So generally speaking, at Sprucewood Star Party, the laser pointers are only approved for the specific time of that event as part of the whole weekend event. For the public event, that's different, but again, because the Sprucewoods requests that they be named on the insurance, Sylvia applies for that, and then as well, she notifies council that on this date, these people will be doing this as a public event, and that then allows the insurance to kick in as well as the use of the global permit. Hopefully that answers your question. Good. Yeah. So the thing is to remember, you are responsible for the compliance with the permit. If you do not follow the permit, you may void the insurance coverage if something were to happen, unfortunately. Hopefully never, if we're using them responsibly as we are, as amateur astronomers, there should never be an issue. Big thing here is Transport Canada sees the RASC as a positive influence in the public. So whenever possible, spend a few minutes to talk about GLP safety hazards. and perhaps even more, promote joining the RASC to learn more. So as part of your public outreach, if you are using GLPs, please tell people about it. Let them know that there is a serious problem with aviation safety when GLPs are used unsafely. So we have one of our goals as the RASC is to educate the public. This is just one other area where we can do that. I'm open for questions now, so I'll check for chat. The spotter is trained and has completed the same course. So, do we have any questions? Okay. I'm going to stop share. So what's going to happen now is we're going to put a poll up, and the poll is the exam. It will be recorded. So what'll happen is you won't see individual scores. What we'll do is when the poll's over, I'll stop the poll, and then I'll review the questions where somebody didn't get it right. And we'll just go over those as there is. So does anybody have any questions before we put the poll up? If you complete the poll and you've been a member for 2 years in good standing, then you will be recognized as having completed the training to be able to use the global permit as issued by Transport Canada.
Can I just jump in here for a minute, Dennis?
Sure, go ahead.
Yep. Okay. So I just wanted to mention at the beginning, Dennis mentioned that if you want to be considered for the certification, we need to have your name, like your first and last name, so we can identify the member. I've sort of, while Dennis was talking, I was sort of picking a few people here and just trying to notify them. Graham W, if you could go in, and if you want to be included, please modify, just rename your instance. You just go into participants, find your name, right click, and then hit rename, and then you can just rename yourself. Reason for that is that when we generate the report at the end, that will be, your name will show up in the report. So Dennis will need to know who it is. And Stan, I'm assuming that's Stan Runge. So I guess you don't need to do that. Anyway, yeah, so that's it. Thanks, Dennis.
Okay, so polls. I'm going to see if I can call it up, and if not, I'll get Ed to do it. Okay, here we go. So I'm going to launch the poll. There are 20 questions. There's no super real long time limit. I'll be able to see that there's 24 participants, and when 24 people have finished, then we'll begin the review. It does not take, these are not difficult questions, so just read them and you shouldn't have any problem at all. So we're going to launch it now. And Michelle, yes, the spotter has to be GLP certified. And you can start answering anytime. Everybody should see a poll now in front of them. And one person has indicated they're not doing the test, so that's fine.
I can't figure out how to answer.
I was gonna say the same thing.
What are you seeing in front of you?
I click and nothing happens.
The questions and answers, but no option to select an answer.
It's almost like I'm seeing the percentage of people who answered,
Okay.
not the poll.
Okay, Dennis, let me see if I can launch it here. So
Okay.
I'm just going to end the poll.
Yeah.
Okay, I'll just hit, yeah, there we go. Okay.
Oh, it seemed to work for me.
I wonder if it's because they're co-hosts.
Oh, you know what? Maybe Michelle and I are both co-hosts.
Yeah, co-host.
Oh, okay. All right. Okay, can we just stop for a minute? I'm just gonna, sorry about that, everyone. I'm just going to, let me just end the co-host, okay? So
yeah, remove the co-hosts.
Yeah. I'm assuming, Dennis, you don't need to do the test.
No, I don't need to do the test. My name's on, mine's the signature that goes in for the permit.
Yeah, I know. Sorry, I'm just kidding.
Yeah,
Okay.
same as yourself, Ed.
Yeah, hang on. Yeah, yeah. Don't worry about me.
Okay,
We'll catch up later. Okay, so there, I've removed those.
so
Okay.
let's everybody try again, and sorry for those if they started reading it. We'll go through it again, so.
Nope.
No, I don't have the same thing as had before.
I had the results up.
Results. Before I had the proper questions, now I've got results, the spotter exam results.
Yeah, same here.
Okay, hang on.
Same.
Yep, likewise.
Okay, hang on. I'm gonna try relaunching. Okay, I'm gonna hit relaunch. Okay.
Looks like it.
Yeah,
That was good.
Okay,
Yep,
good.
that's
There you go. Okay.
Gotta like those technical Zoom things.
I'm still not able to hit the submit button.
Yeah, what does that mean? Maybe when you finish answering, you can submit?
I think you got to do it all.
Yeah, yeah. You have to. All of the questions are required. So there's 20 questions. So you will need to do all 20 questions and then hit submit.
You have to answer 20 questions to get that permit.
That is correct, yeah. We'll review, don't worry if you get one wrong, because I'll review it. It's corrected to 100%.
I'm sorry, I'm not muted. I was telling Krishna.
elevator music. Hoping that it will go up. Things will go up from here. So we're just got a couple more people and then we'll be reviewing it. So it's coming along nicely. Do 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 do.
Hey, Dennis, do
Do.
you see
Yeah.
all of our happy faces? Are we
I can see
recording?
everybody's happy.
3 for 1.
I have a plan for you.
Okay.
So far, it looks like 19 people have completed.
Yeah, so I'm just gonna ask there's 3 other participants. So the question is, if you're not doing the poll or the exam, can you please put your hand up so that I know? And then I can close out, we can close this out. Or if you need more time, can you please put your hand up? Or just let me know you need more time.
Just to answer Kamala, I see you put both your names when you rename, so it should appear in the report. So it should
Thank you.
include both. Welcome.
That's a giant that's a giant effort when we are doing here. So
Okay, well, Ed, I think we'll end the poll. I don't see
Okay,
anybody asking for more time of that.
Yeah, can you just let me do that? I want to just make sure
Yeah.
I capture the report.
Yep, and then share. Okay, so
Yep, hang on.
I'm gonna now review the results. So the first one, what document deals with laser possession? It's technically the interim order. So the interim order is the correct answer, and there was a few people had answered differently. So it's the actual interim order with Transport Canada.
Okay, can we, sorry to interrupt. Can everybody see the results on your screen?
No.
Nope.
No, okay, hang on. Have a look now. Can you see?
Got it.
Okay, good.
Yes.
All right, sorry.
Yep.
Okay, good. Dennis, sorry, go ahead.
Yeah, okay, so as I mentioned there, the first one, document deals with laser possession, was the interim order, which still parts of it are still in effect. What regulation deals with projecting bright lights into airspace is the Canadian Aviation Regulation 601.22, and everybody got that one right. What is the maximum rating allowed for possession of a green laser pointer? 5 milliwatts is all you're allowed. Where can you check to see if you're?
Hold on, you should scroll down so we can see the results.
I am.
Ed, do you want to scroll it down so you can see
You can
the
scroll down
Individual
yourself.
scrolling.
You can scroll yourself.
Yeah, you have to do it yourself, yeah.
Oh, okay. Yeah, because I've been scrolling. I wondered, okay. 5 milliwatts. So there's a couple that missed on that. Where can you check to see if you're within a 10-kilometer certified airport zone? The TC interactive map, not Google. Transport Canada interactive map, as I showed you how to get there, and that's just simply type in Transport Canada interactive map. Can you use the RASC GLP permit within the 10-kilometer zone on the interactive map? No, it is only for use outside of the 10-kilometer zone. So you cannot use the RASC GLP global permit within the 10-kilometer zone. You have to apply for a special permit. So that has to be done separately by the individual group to Transport Canada. So the answer is no. How old must you be to be certified as a GLP user spotter? 18. Everybody got that one correct. Who must you notify before you can use the RASC GLP permit for an event? The executive of your local center. not the executive director of RASC. Mr. Groff would probably not like that, especially if it becomes popular and all centers start doing that. So it's the center executive at the local council. How much notice must you give the approving body prior to the event? 8 hours is the minimum. 8 hours. All these other times are good, but 8 hours is the minimum. What must be in your notification to the approving body prior to the event? So you need the name of the certified GLP user, the certified spotter, location of event, date and time of the event. Which is, some people put, they left out name of spotter, GLP user, and certified. Yeah, so the key difference is certified. Number 10, what must you have with you at the event? You must have your membership card, your certification, copy of the RASC permit, and a copy of the RASC insurance. So B was the correct answer. What class of laser is acceptable by Health Canada? Class 3A or class 3R. That's what's approved. 3A or 3R. Where must the spotter be located? Darren, you didn't answer B, did you? The correct answer is C. In a position to observe the sky being used and to sound warning if a plane is seen. Number 13, can you shine a laser at an airplane? No. Everybody got that correct, right? Number 14, what must you do when the event is over? File a report to the center executive about the event with a number of people, etc. Everybody got that right? If you do not follow the policy, procedures, rules of the RASC Transport Canada, can you be charged? Yes, you can be charged because you are in non-compliance with the regulations. Permit states basically that we will comply with the regulations and as we've agreed to. Who is responsible to promote GLP safety? Every member of the RASC. Everybody got it right. Thank you. How do you prove you are a member of the RASC in good standing? Your membership card. 19 out of 19. Everybody got it correct. 18. How long must you be a member in good standing of the RASC to be trained, certified as a GLP user spotter? 2 years. Can a GLP of 5 milliwatts be dangerous to a person's eyesight? Yes. Everybody got that correct. Should you be certified as a GLP user spotter? Yes. One person said no. But the correct answer is yes. Does anybody have any other questions on this before we have? Yes, we are all 18. I have a caveat. The use of deal pointing near the horizon, they should be aware of people standing around them. Yes. Yeah. So of course the expectation always is that the actual GLP user uses the laser and doesn't point it in the direction of anybody at any time. So hopefully that and is aware of their surroundings, as Michelle has mentioned in the chat. Any other questions or comments before we stop sharing the results? Good. So we'll stop sharing. All right. Does anybody have any other questions or comments? Because that closes off that portion. And so just before I close off the meeting, I just want to point out a few things. So we talked a little bit tonight about early on about how to be volunteering and things you could show people at a public outreach. And I don't know if anybody picked it up when Russell did his little bit of a talk about moving over from groups to IO. He mentioned he's a brand new member, basically, you know, and he's a member of council. So please, when you look at all the things that we're looking to try and recruit volunteers for, as well as eventually council here come the fall, just because you're new, you bring a lot of skills and things to the organization and I encourage you to volunteer. Don't let that hold you back because you say, well, I'm brand new. I don't know much about astronomy. You can learn and you can come in and you bring all your skills from everything else that you do. And please, I encourage you to volunteer. So another thing there is Kamala, just tonight, talking about doing public outreach in her local community. Anybody can do that. The only thing we ask is let us know that you did it in advance, ideally, because then it becomes officially covered under the RASC volunteer insurance. First Fridays are happening again at the University of Manitoba, or not the University of Manitoba, my mistake, the Manitoba Museum. And I encourage you to volunteer and go out and show the public our relationship that we have with the museum of, and that the partnership that we're building between us to be able to promote things as we go. And also to remind everybody that next month's meeting will be at the Glen Lee and is the barbecue. If for some reason it's the site's not acceptable by that time, we will let you know of an alternate location. Michelle, I see your hand is up.
Yeah, could someone explain that museum thing more clearly? It's a bit vague to me.
Oh, okay.
One time it was clear out and they canceled, but apparently they have indoor activities, so I'm not sure exactly what's going on or what's expected in general.
Okay, so what it is Downtown Business Association on the first Friday of the month has an event where all the downtown businesses stay open late. Primarily all those businesses in the area, all the restaurants and that down by the museum. So out in front of the museum where the dome is, between the dome and one of the entrances, is a nice little area that's fairly well protected from the wind and that. Is where we will set up as the RASC, and then we set up our telescopes so that people coming into the museum or leaving the museum have a chance to look at either the sun or possibly the moon, and whatever else we can show them at that time of night. Now, obviously, as Brian mentioned, it's not the best time of year for doing that, but it gets us out in front of the public, lets people know we're there, and it also gives the museum another opportunity to promote their programs through us, okay, by encouraging people to participate and go down and see what the museum has to offer. And, you know, as an organization, one of our goals is to promote the sciences and the STEM trades. And this is another way of being able to do that by that one-on-one experience that we can give people. So does that help explain it a little more, Michelle?
Yes, thanks.
You're welcome. For those that asked, yes, everybody's passed because we reviewed it and corrected it to 100% is how it works. And that's why we have the 3-year limit on the certification, because we brought you up to 100% knowledge in theory is how it works. And this is a process that's acceptable to Transport Canada. And then over 3 years, you tend to lose a certain percentage of knowledge every year, generally speaking 10%. And then we have to bring you back up to 100% knowledge, or if there's been any changes in the regulation or the use of the permit. So again, thank you, everybody. Appreciate you all coming tonight. And what will happen now is we'll move into our friendly meeting where everybody can socialize and get to say hi and catch up. And on closing, just remind everybody, the August meeting will be in person at the University of Manitoba. I have to go, so we'll talk to you all later and have a great evening. Bye-bye.